This is a screencast for a CSC 791 DevOps Continuous Integration Pipeline project. It consists of build, test and analysis, deployment, and special milestone. We have used Direwolf, which is a Ruby on Rails application, as our target project. We've used GitHub, Jenkins, AWS, Docker, Redis, Ansible, and New Relic. For the build milestone, we've used Jenkins as a post-build server, which we are running in a Docker container. We have dev and release branches in our project. Post-commit script triggers build for these branches when a commit is made on either of these two branches. When a build is successful, it triggers a git clean as post-build task. We have configured Jenkins to send out emails to the contributors in case of build failure. We have used RSpecGem for unit testing our application. For measuring the coverage of the test, we have used SimpleCove, while RCove has been used for displaying the test results. In order to improve the test coverage, we've used fuzzing technique. We can see here that the test coverage has increased after the use of fuzzing technique. Jenkins has been configured to run static analysis as a post-build task using excellent gem. A Python script is also used as a post-build task for extended analysis, which prints the code to comment ratio. We have set a threshold in Jenkins for a code coverage. Build is marked as a success only if the code to comment ratio is above a certain threshold. This is the architecture of our deployment strategy. We are running Redis, Jenkins, and registry in Docker containers on an AWS instance. When we run configure script, it provisions two AWS instances, one for canary and one for release environment, the IP addresses for which are then updated in the Redis store. Redis sends 10% of the traffic to canary and 90% to production. We have configured a post push hook for release branch which will trigger build and test on Jenkins. On the success of that, it will create a Dockerized image of our application and push it to the registry from where it will be pulled in a Docker container. This will deploy the application to release. Here we see that our application has been successfully deployed. In the case of Canary branch, git commit will trigger Jenkins build and test, on the success of which deployment will be triggered for Canary. Here we see that our application has been successfully deployed. We have configured feature flags in Redis such that when the flag is set to false, admin user cannot be created. When the flag is set to true, we see that admin user can be created successfully. We are using New Relic to monitor our canary and release environment. We have configured rules such that if memory or CPU usage crosses a threshold, alert is sent out and traffic to canary is cut and routed to production.
For a special milestone, we've implemented two new features. We've introduced a new deployment strategy where if requests per second exceeds 1, which is a custom threshold we set for now, another Docker container is provisioned and some part of the traffic is diverted to it. If requests per second fall below 1, then Docker containers will be scaled down. Here we can see that the current requests per second is about 0.4, so we have a single production instance running. Now, when the number of requests per second goes above 1, we are going to be scaling up and provisioning one more Docker container running an Ansible script. This is an auto scale up. The Ansible script would provision a new container as well as make entry into Redis, from where we can now divert traffic to both new provisioned servers. Here we can see that production 1 has been provisioned. Now traffic will be routed equally to both production 1 and production 0. Here we can see that production 1 has come up and traffic is now successfully routed to production 1 as well as production 0. Now in the case that requests per second goes down below 1 or 0.5, which is a custom threshold, we will scale down a server and production 1 will be killed. Here we can see that we've got only production 0 left and all requests will be routed only to production 0, as you can see in the video right now. Our second milestone is flame graphs for visualization of a crash report. We have configured our application for using flame graph gem. Here we see that an application crashes, flame graph will be generated for visualization of our stack trace. In the video, we can see that we'll be killing off MySQL so that our application crashes when it tries to interact with MySQL. Now we can see that in the video that the application has crashed and a flame graph should be generated for this. We can see here the flame graph for our crash report.